I mean, it all starts with like, what's the end goal? Like, what do you actually want the machine to predict?
Algorithms help the computer learn from data, and then predictions are the result of that learning.
Our behavior is analyzed with those algorithms you described. And then over time, the platform learns what I like, what I don't like, and then appropriately predicts what I might like to see next. That's what makes them so addictive.
I'm going to go out on a limb here and say most of the people on social media have no idea that they're interacting with machine learning. Last week, we started off our episode with relatable examples of AI. If you remember, you had said facial recognition, I had said maybe radiology and healthcare. Those are actually also examples of machine learning. So today, we're focusing specifically on machine learning, starting with what exactly is machine learning. And I would love for you to define that for us.
Okay, yeah. So from what I understand, like last week we talked about broader AI, and that's a broader term, and then machine learning comes under AI. It's a form of AI where I'd say a machine is learning patterns from a data set, and this results in the machine doing something. So making decisions, making predictions based on these learnings.
So, can I share my definition and how I would
Yeah,
define it? And then you
please,
can
please.
let me know how you think I did, because we did
Uh-huh.
this last time too. When I hear machine learning, I kind of visualize it in my head. And what I picture is a computer, and the computer is getting better at doing something on its own without a person sitting there and giving it directions.
Mhm.
I get stuck with how does the computer actually learn? Did someone pre-program the computer to learn?
Yeah, yeah. This is where it's interesting because how do humans learn, and is a machine doing the same thing? And your definition is great. Like it's a computer doing something on its own without explicitly being given a bunch of rules. But so the way that I understand how it actually learns is basically from a large data set. So what does this actually look like? Well, let's say we're trying to get train a machine learning model to be able to distinguish images of cats and dogs. So in the end goal, I'm going to show it a picture from my camera roll of a cat or a dog, and it's going to say that's a cat, that's a dog, and it's going to get it correct. That's what we want it to do. The way we would get it to learn the difference between a cat and a dog is first it would be fed a bunch of input data, in this case, images of cats and dogs, with each of them having a label. So I'd give it an image of a cat and say cat. I'd give it an image of a dog and say dog. And I do this on a mass scale. And during this training, the model firstly processes that input data and then makes a prediction. So it'll look at the image and then it'll say, okay, this is a cat or a dog. And then it will evaluate itself. So it'll then look at the label I gave it. So it'll see the image, it'll say, make a prediction, this is a cat. It'll look at the label, okay, actually it's a dog, and then it will adjust its internal parameters to reduce the error. So there's a bit of technical stuff going on there, but then every single time it makes a new prediction and looks at a new image, it gets that slight bit better, the error reduces that slight bit. And over, hundreds of thousands of images, the model has learned what is a cat and what is a dog. And then it's finally tested on a new image, one that's not been part of the training set, a new image of a cat or a dog, so that we know that it's not just memorizing the data, it's actually learning and predicting. Yeah, that's essentially how it learns.
So I guess I can also compare this to transportation. I'm trying to see if I can better understand this. Let's say we want a computer to become an expert on transportation. We could then, in theory, feed it information about trains, buses, bicycles, cars. It learns about these different modes of transportation
Mm.
and then can make predictions or notice patterns and similarities and differences in order to either respond to a question or do a certain action.
I mean, it all starts with like, what's the end goal? Like, what do you actually want the machine to predict? Um,
It's so interesting. I don't think that I would actually truly understand it unless I was working with machine learning directly and training it from the beginning.
Yeah. I mean, another way to think of it is just literally think of it like a human, right? Let's say you're trying to train a 5-year-old to tell the difference between a cat and a dog, and you show it a picture of a cat and say, this is a cat, okay? And then you show it a picture of a dog and say, what is this? And it'll go, cat. And they say, no, that's a dog, okay? Then you show it another picture of a dog. You say, what's this? They say, cat. No, that's a dog. Then you show another picture of dog. What's this? Oh, dog. Ah, okay. That is a dog. You got it right. And over time, the child,
Repetition also,
yeah, yeah.
and it becomes familiar. Of course, by the way, when I was trying to better understand machine learning, I did some more research as I always do. There were two words that kept repeatedly coming up, by the way. One was algorithms, not surprisingly. One was predictions. I asked ChatGPT why algorithms and predictions were words associated with machine learning. Here is, and I'm quoting exactly what ChatGPT told me. Algorithms are like recipes or step by step instructions that teach a computer how to solve a problem or make a decision based on data. And then for predictions, it said predictions are the guesses or outcomes a computer makes after learning from data, such as guessing what you'll buy next based on your past purchases. Super helpful, actually. But
Mm.
where does the data come from? I guess a photo of a cat and a dog would be an example of data.
100%. Yeah, yeah. And again, it all starts with that question of what's the end goal of the model? What do you want it to be predicting for you? And so going back to the cats and dogs example, the data would be a bunch of pictures of cats and dogs, crucially with a label correctly identifying each cat and dog. That's a super simple example. Let's take a more familiar example, real life example of ChatGPT, right? OpenAI has a bunch of models that they've trained. What data are they actually trained on so that it can converse with us about whatever we want to talk with it about? And so ChatGPT is trained on things like the internet, so public web data. I remember reading that it was trained on, I think, Reddit stuff as well. I mean, basically a bunch of stuff on the internet it's trained on. Publicly available books, Wikipedia, academic papers, all these sorts of things, which makes sense, right? Like if you want a conversational model that can adapt to anything, you want to train it on anything and everything. And the internet's a pretty good place to start for that.
It's pretty amazing.
Mm.
So, okay, algorithms help the computer learn from data, and then predictions are the result of that learning. The most interesting part to me, though, of all of this is that humans are the ones who are adding the algorithms to the computers by like writing some software for it, I imagine. And
Mm.
then the computer uses the algorithm to learn from data and make predictions. So without humans, machine learning wouldn't even be a thing.
Yeah, completely. Yeah.
And the other thing that's really funny to me is because do you know what the first thing I think of when I hear algorithm is?
Well, it might be the same as what I think.
Social media.
Yeah, TikTok and yeah.
Because I feel like anytime I hear about TikTok, Facebook, Instagram, LinkedIn, people are always talking about the algorithm because the algorithm is part of what decides what content you see, right? It pays attention to your behavior on the social media platform. So, a post that you either like or comment on, who you're following, what you're watching versus what you're swiping past. And then it also decides what to show you next. So, anyway, social media is basically running on machine learning then.
Social media uses machine learning to decide what content you see, what content I see. And yet our behavior is analyzed with those algorithms you described. And then over time, the platform learns what I like, what I don't like, and then appropriately predicts what I might like to see next. And yeah, that's what makes them so addictive.
I'm going to go out on a limb here and say most of the people on social media have no idea that they're interacting with machine learning.
Mm, yeah, yeah. I mean, it'd be interesting to see what people actually think. Yeah.
So let's switch gears a little bit, but still on the topic of machine learning. Yesterday, Salesforce and NVIDIA announced a collaboration related to autonomous agent and interactive avatar experiences. So autonomous agents, for those who are unfamiliar, work through a combination of machine learning, natural language processing. Some of us know that as NLP, and also data analysis. There's the word data again. And from what I understand, essentially what's happening is that an autonomous agent takes a set of data that it's given and then uses a machine learning algorithm to better understand this data. And then, based on whatever the agent learns, it performs some sort of action. So, in this case, where machine learning is being used to create, let's say, a more effective interaction between businesses and their customers, would you consider machine learning to be the brain behind the autonomous agent?
Yeah, 100%. Yeah, I'd say machine learning creates the agent, which then understands which tasks it should perform, decides which task to perform based on an input, and then executes that task pretty much just as, my brain does.
So, then in theory, what types of actions could an autonomous agent actually do? I'm thinking customer support off the top of my head.
This is where it gets really interesting. And I've actually been diving into the world of AI agents and specifically AI SMS agents in the last few weeks at ClerkChat. And yeah, the way I think about it is you've got an AI agent that performs a role, right? So, like you said, a role could be a customer support agent or a recruiter or a sales rep. That's a role. And then each role at a company performs a bunch of workflows. So you could break a support rep into maybe 10 different workflows. One is answering emails, another one is going on meetings with clients to solve their issue. Like each of these is a workflow. And then with each of these workflows, there's a bunch of tasks that you perform to complete that workflow. So resolving an issue over email might be reading an email, looking at the issue, writing an email, sending an email, just as an example. The way these kind of AI agents execute actions or perform tasks is kind of in that reverse order. So starting with those tasks, then combining a bunch of agents that can perform those tasks to do the workflow, and then combining a bunch of agents doing many other tasks to create many other workflows to create an overall AI agent that's performing a role. So that's how I think about it. It gets kind of complicated, but it's all about the building blocks and building it up into a bigger agent is how I view it.
It does sound complicated, but I think the way that you explained it with building these separate agents that then can kind of work together to be this big umbrella agent
Mhm.
makes sense to me.
Role, workflow, and tasks is the way I think about it.
Role, workflow, and tasks.
We're both doing a role, and a workflow that we both do in our role is the podcast. And the tasks that go into that for both of us are a little bit different because our roles are different. But then we each do tasks that fulfill the workflow of podcast. That is one of our many workflows, part of each of our roles.
I'm really finding it fascinating in general just to see how machine learning is pushing so many boundaries. And I'm really curious to see the implemented changes for Salesforce from this partnership with NVIDIA because Salesforce has already implemented plenty of AI prior to this collaboration announcement.
And Salesforce is one of those platforms that has access to those vast amounts of data to really make AI perform well. So, same, I'm excited to see, interested to see, I should say.
Totally. So we've chatted about machine learning and what it can learn from data. My question is, how do we know whether what the machine decides is accurate and fair? I guess that's a conversation about bias.
Yeah. And this is something that can never, well, at least currently can't be 100% accurate because it's in the name, right? It's machines are learning. And as a human would learn, mistakes are made during learning, which actually makes you learn better. And so, yeah, to describe machines as learning and not expect the same standard would be a bit foolish, right? So yeah, 100% there's mistakes that are going to be made, especially when it's based on probability. It's it's prediction.
Do you think that it's fair to say that businesses should be like mindful about what type of data they use when they're training a machine?
That's definitely a core concern. And things like increasing diversity of data. So not just taking, like if a model's trained in the US, not just taking data from the US, and if a model's trained in Europe or China, not just taking data from there, from those locations, taking data from a wide range of sources will improve learning. You know, the engineers and researchers actually building these models, the way, the way they kind of fine tune and all of these sorts of things, even them coming from diverse backgrounds, locations, cultures, will impact how the model learns, right? I mean, just literally exactly the same as learning with a human. Like if you were just talking to one person, you could still learn a lot, but there could be gaps, right? Because that person would have biases. And then all of a sudden, as soon as you talk to two people about learning about a topic, you start to fill those gaps and learn more.
Also, though, I was just thinking about that. Even if you're talking to, forget about the second person, even if you're talking to one person, talking to one person on only one day also creates a bias because if you had that same conversation with that same person on another day, the response might be different because there's so many factors involved that drive a conversation, right?
My thing is always to compare it to a human. If I was just listening to a conversation between two people, I'd have a different perspective. Whereas if I was like watching a video and listening, because then you see body language, you see their emotions, not just the tone of voice and what they're saying. Yeah, completely. It would change.
Ooh, we should ask our listeners and viewers that.
Oh, yeah. Yeah, let us know. Yeah.
All right. Well, I think we had a great chat this week focused on machine learning and looking forward to next week's topic.
Yeah, thanks, Joel. Looking forward to speaking.
Talk soon.
Bye.